Now let's look at this graph, but in the opposite direction. We're going to start up here where we have a gas at a high temperature, and we're going to move backwards. Instead of adding heat, we're removing heat as we go from right to left. This point at which the phase changes is still called boiling or condensation point. It's the same temperature, and the point at which the phase changes again, going backwards, is still the same point, and in this case we'll be calling it the freezing point. Alright, so we'll start with that gas, and it's very, very hot. Particles are zipping around really fast, and then what we do, we begin to remove energy. So as we remove energy, we're going from right to left, and notice that the line is also moving downward, and so that means the temperature is decreasing. So the temperature will decrease until it reaches the point, the boiling point, or condensation point. In the case of water, that would be 100 degrees. At that point then, remember, in the gas, the particles are zipping all over the place. At this point, they slow down, and they've slowed down to the point that the attractions between them begin to pull them together. They have less energy than they did up here, and so the attractions are able to pull them close together. They begin to gather and form little droplets, often on the surface of a solid. Our experience with that most commonly is on the outside of a glass of iced tea or ice water outside on a cool day. At that point then, once the particles stop flying freely about and begin to gather together, they are flowing over one another, but that's the point at which they begin to become a liquid. So this phase here, this part, probably phase was a bad choice of a word, but this part of the graph, this horizontal part, is the phase change, but it's the phase change from a gas to a liquid or condensation. So as time goes on and there's less and less energy, more and more of it changes to a liquid until finally it's all liquefied and it's dripping down the sides of our glass. At that point, there's no more water vapor in the air. In reality, we'd never get to that point, but in a closed system we might. And then all the substance is in a liquid form. If we continue to remove energy, then that liquid gets colder and colder and colder. And notice here the temperature is going down. Here, during the phase change, there was no change in temperature. As the energy was removed, it caused the particles to slow down enough that they were not able to fly freely. But that energy loss was totally going into changing the phase from a gas to a liquid. Now, once it's liquid and energy has continued to be lost, then the temperature of the liquid can decrease. And this entire line here, C, represents the time during which the substance is a liquid. Finally, it'll get down to a point where it hits its freezing point or melting point. In this case, we're talking about freezing. Remember that the particles in the liquid are flowing around one another, but staying kind of in the same region. They're not flying out into space anymore. And when it hits this temperature, the temperature at which the substance will freeze, then the particles have slowed down to the point that they really don't move out of place, and they begin to fall into place and develop a rigid structure, and all they do is vibrate. So again, as we're going from right to left along this line that represents the phase change, that represents freezing, what we see is more and more of the substance has changed from a liquid to a solid. And finally, when we get to this point, all of the liquid has become a solid. Once it's solidified and we continue to remove energy, then what happens is that the temperature of the solid will decrease. So as long as, in the case of water, the freezing and melting point is 0 degrees. So during this time, when we've got some solid and some liquid that's becoming a solid, the temperature will stay at 0. And it's not until it's all a solid that the temperature will begin to go down below 0. Now, of course, when I say 0, I mean 0 Celsius, right? That's not the freezing point in Fahrenheit. Okay, likewise up here, when the substance is condensing,